How y'all doing? All right. You all feeling really meta today? All right. Let's talk some comics and science fiction and science and all sorts of good stuff. I'm Steve Snyder. I'm the president and CEO of the Fleet Science Center. And if you find yourself asking, what's the Fleet Science Center? You're in luck. I'm gonna tell you. It's San Diego Science Center. It's an interactive, there you go. People know. It's our interactive, hands-on science center. The world's first domed IMAX theaters. So if you like those IMAX shows, and then we're the reason for that. And if you get nauseous in them, we're the reason for that too. So I apologize in advance. This panel is going to be a really interesting one, kind of talking about this notion of genetic mutation. Are we all going to be superpowered someday? Which would be great after walking the floor for all day. I could really use that levitation superpower, or maybe that one that grows you new legs. That would be a good one too right now, because man, I'm hurting. But okay, yeah, we're going to talk about that. I'll, as a preference, I'm a physicist, so the whole biology thing I did as an undergraduate work as a fruit fly farmer. It is a thing. You know, the fruit flies have to eat, and what they eat is really awful. So if you want some, I still have the recipe for what fruit flies eat. It's pretty gross, but apparently the scientists learned all sorts of good stuff from it, and that made it all worthwhile. But more worthwhile is going to be our panel today. We've got lots of interesting folks here from all sorts of worlds of physics and biology and producing and writing and all sorts of great stuff. So let me introduce the panel. We'll get going. Immediately to my left is Greg Titley. He's the executive producer and writer for Agents of S.H.I.E.L.D. Yeah. Next up, we have Akilah Cooper, who is a producer and writer for Luke Cage. Man, their order is following my list. This is so awesome. Next up, we have Dr. Frances Barron. She is a scientist, VP, R&D, and Regulatory Affairs at Nanomedical Diagnostics. And we have Dr. Brett Goldsmith, scientist and the Chief Technology Officer at Nanomedical Diagnostics. And last but not least, Troy Sandberg, a PhD student, bioengineer, and the Siebel Scholar at the Jacobs School of Engineering at the University of San Diego, University of California, San Diego. All right. So welcome. Let's start with something. So I'm just going to throw this to our two creatives here. I really shouldn't say that. Science is a very creative pursuit, but you know what I mean. The folks who get labeled as creative when they go out and do their work. For these two folks, we talk about metahumans, right? That's a term we used all too often these days. It's all over TV and obviously comics and movies. So when you're looking at a character, what is it that makes them? What makes their superpower worth them having, worth writing into a script or building a character around?
I would think generally when we're coming up with anything, it starts with wish fulfillment.
Oh, yeah.
Yeah, it's
totally.
like you think back to your days as a nerdy kid. Like, what powers would I like to have? And so I think the metahumans, anything that's enhanced, whether it's strength, mental powers, invisibility, you name it. And I think pretty much every superpower has been done at this point. But it always starts with wish fulfillment, and then it always ends with what can we afford to do? Super hearing. It costs nothing.
Yeah, exactly what Craig said. It's always in the room. It's like, what would you want to do if you could have any? It's that question. It's like, what superpower would you want if you could have any of them? And you start to think about what you would like to do in your everyday life, and that what you would want to get away with, and then you apply that to a character, and it also helps. It's like to think about, okay, well, we have this. How's it going to help the story, like either character-wise or plot-wise, and then go from there.
Yeah. So, wish fulfillment scientists, is that what you guys are doing too?
Yeah, essentially. So, when you see something on TV that looks really cool, like Luke Cage skin, right? What happens is then some really wealthy people say, "Gee, I want Luke Cage skin," and they come to me and they say, "Okay, make me Luke Cage skin," and I have that exact same conversation of, "Well, okay, this is what we can do, and this is how much we can afford to do. So how about this?" And it's really that balance of what is financially possible, but that wish fulfillment that seed has to be planted somehow.
So a question for you, when you say that they come to you for Luke Cage skin, are they expecting you to give them something that they can inject, or have they seen the show and they want to be put in a prison and put in a tube in an experiment, or, you know, are you building them an exosuit? Like, what are their expectations when they give you that request?
It would be nice to do some of those things, but no, they want it as easy as possible.
Okay.
Right?
And
No.
full disclosure, that was me.
Yeah. Yeah, that would be, but yeah, no, they want it as easy as possible, right? So they think, hey, people want to see this, and so you guys go figure out how to make it. And our job is to say yes, we'll make it.
Yeah, and then, so I'm the biologist in the company, and he's the physicist, so it's kind of, we have lots of interesting conversations. But I also do a lot of the regulatory affairs, so we probably, if you've ever taken a drug in your life, one that a doctor prescribes you, it has to go through the FDA in the US. So I'm always saying, whoa, whoa, whoa.
She won't let me
no.
experiment on people.
Yeah, basically. Yeah, it is. So that's where, like, I'm interested in kind of the ethics about it all, right? So you bring up some interesting things that go on, and there's some great plot lines, and then it bleeds into pop culture. And then we have people that are now like injecting gene therapy into their skin on YouTube and to like change themselves. So like that's like an interesting sort of dynamic that comes about, and how I'm always interested in how the ethics play into things.
Well, and I
Within the
imagine that
show?
from,
No, well, just in general. I mean, I'm not saying that it came from you guys, but,
well, but
you know.
But again, a lot of the ways that writers use the powers, right,
Right.
is to explore ethical issues, right? Is that a kind of a part of the opportunity where those powers, or appearance of powers, or existence of powers, can be a plot point in of itself. So what guys? So okay. So if you guys are imagining the things that no one's imagined yet, what's got you scared?
Oh man, that's a big question. I don't know, I was just thinking about this earlier today, that I think what scares me most isn't the powers, but sort of the common ground I think a lot of people at Comic-Con have, is we always looked up to superheroes because we felt disenfranchised when you were younger, unaccepted, and so you look at these people with powers and it would inspire you. My personal fears were spending so much time on how to improve the external, speed and strength, all this, and we're spending no time on how to improve the internal, and I don't think science can do that yet until we find the soul and then can manipulate it.
Or, you know, nanochips in the brain.
Or nanochips in the soul. I think that's what we need. So I think that's my biggest fear, is that we're focusing on the wrong things sometimes.
Yeah, it's hard to find people who have the moral center that you find of like Luke Cage or Agent Coulson, right? I mean, like those people are amazing on the show, and in real life you don't have that.
Yeah,
Well,
but
you
there are also two characters who had that thrust upon them. Like, spoiler: Luke Cage was falsely accused of a crime, sent to a prison where he was experimented on, survived the experiment, and it escaped. And there's like a whole history behind that with like the, you know, Tuskegee experiments on black people that we like deliberately like would address within the show, and like those, you know, marginalized peoples who are experimented on against their will. So that's kind of, it's like, who is going to regulate this, and who, you know, what will happen to marginalized people if these technologies become popular?
Well, that's a good one for regulatory affairs.
Yeah, well, and so one of the interesting shows that I just watched and fell in love with, which is Orphan Black. So this is a little bit closer to my home because, yeah, right? Because I'm big into cloning and stem cells, and you know, the idea that they're barcoded and that the IP is in their DNA was like a fascinating twist to have on there. And now what is the ethical implication of creating these clones that are people, but they're also property, which goes back into like experimenting again, right, on people without their will, in this case their embryos. So it's just, you know, I think the power of the writers is to take these pop culture science too that are coming out, like cloning, and starting to work through a lot of these ethical situations that you put characters in, they have to make these decisions, and then that it's like a feedback loop, right? Because it causes us to think critically about how do we want to self-regulate and regulate experimentation without restricting our ability as scientists to push the boundaries, right? Because no, we don't want to be experimenting on prisoners. So anyway.
So when we talk about pushing the boundaries, Craig mentioned that he thinks that they've come up with all the superpowers that there are. I'm going to ask the scientists, what's going on there that they haven't thought of yet?
Well, I mean, I think probably the best superpowers in terms of physical feasibility and getting people actually with these powers, you look to nature and the billions of years of trial and error that it has gone through, and it has created some incredible powers. I mean, there are electric fish that can kill a man with a strong enough discharge, and there are birds that can sense magnetic fields, and creatures that can see into different wavelengths of light that we can't see into. And we are all living creatures that evolved on this planet, and so the code which we're written in DNA is the same for all of us. I'm, for my PhD research, doing some work on cross-species gene swaps, and I took bacteria and took out some of their genes and put in various foreign copies, including human. And at first it doesn't work at all, but then if you evolve them, they get mutations that let them assimilate the gene because I arranged the conditions so there's a very strong selection pressure. And it just highlights the fact that we're all made of the same stuff. And so if nature has figured it out in the natural world before, it is feasible to give those powers to humans. So all sorts of crazy things, altered senses, abilities. The real limit is probably physics. So we're not going to get teleportation, things like that, because we have non-biological reasons to think that's not going to happen. But super hard skin, that's totally feasible. Super advanced cognition, senses, and being able to. There's research into expanding the genetic code and going beyond regular amino acids and going to non-natural amino acids. A lot of work's being done in that, and so that will actually increase even what we can do above what nature can do. And we'll be able to start to introduce new novel metalloproteins that nature has never used before, and we have to synthesize, but then we can get it working in living systems. And there's work getting it working in bacteria right now, and so it's not infeasible to think of it eventually working with humans.
Yeah, I think as a physicist, I have to say that's true. we limit what you can do, but there's a lot that can be done within the confines of basically conservation of energy. So I think that one of the things you get from the physics point of view is this thought that what you have biologically and what we have electronically, they're really just the same systems. They just don't know how to talk to each other yet. There's a couple things that biology can do really well that electronics can't do, like your brain works not as fast as a computer, but at a much lower energy level. And you can take in different food and convert it into energy. And all your neurons and everything run off of electricity, voltage. So why can't you just combine those two things together? And so there's a lot that you can think of when you start thinking about that in terms of what could be done to really make superpowers that start looking like telepathy and things like that that people are working on. And so at least these are the kind of things that are going to come, hopefully in our lifetime.
Yeah, so earlier I was doing two scientists walk in a bar. Anyone who's local in San Diego, please Google that and go to the next one. But they asked me, okay, when are we going to regrow limbs, right? Because that would be cool. That's one thing that I would love to be able to do.
And that's all on biology.
Right. Well, okay, you say that. I mean, it is. But I think that one of the ways that we would be able to do it in the near term is this idea of being able to couple electronics with biology. Because there are so many different cell types that make up, our skin. So, right, we think, oh, okay, it's just this thing that we can feel and it sloughs off when we get a sunburn. And they can actually grow it in dishes and they put it on burn victims. But if you do that, you can't actually sweat or grow hair. And that's because how they grow it in a dish, it doesn't have those cell types that make the sebaceous glands, which is what releases our oils and sweats. And sweating actually is really important, as you guys probably felt on this hot day, because it keeps you cool. And so burn victims that have this skin, it's great. They don't lose a lot of water, but they can't regulate their heat very well because they can't sweat. So, so where you get into growing arms and things like that is that you can more easily take your cells and neurons and things like that and grow them over an electronic arm. And then you're more able to start getting the sensations and things like that from an electronic standpoint without having to grow yourself a whole new arm. The other thing, when you talk about conservation of energy, it's really nice that, like in Aliens, where they show they can grow something up or anything in like a week, and that just can't happen. If you've ever felt a baby's head, it's really, really hot. And that's because growing cells and dividing takes a lot of energy, which releases heat. And so you just couldn't do it. So in order to grow it in a useful time frame, like not having to wait 25 years to have a full-grown human heart, you would have to try to cut that time down. And you can do that by prosthetics and things like that. But that's kind of where I think it's important for biologists to get interested in engineering and physics and things like that, because that's cross-functional teams are really how that stuff is going to happen. Anyway.
So, if we sit around waiting for evolution to give us powers, is it going to happen?
No, unfortunately, that's not how it works. It would have to give us, the people who got the powers, some sort of strong advantage in terms of having more children compared to the rest of humans. And that's not sort of the evolutionary pressures shaping human evolution nowadays. We've had, like, evolving to tolerate lactose into adulthood is one of the most recent evolutionary changes for humans as a whole, because when we started domesticating animals, the people who retained the ability to digest milk past infancy got more energy from their environment and literally survived better and passed on their genes better than their peers. So there's not really a feasible path to superpowers by which there would be sufficient selective pressures to guide it that way. But fortunately, we have genetic engineering now, so we don't need to wait for nature to do it, and we can do better than just straight evolution, because evolution is it's trial and error and totally random, and it goes with what works. But that doesn't mean it's the best, and there are aspects of our physiology that are objectively non-optimal, like our retina's developed in a certain way where the nerve endings go through the lens, and so we have a blind spot built in, and when you look in like cephalopods, their eyes evolved in a different way, and they just don't have that blind spot. They're objectively better. And so there's all sorts of tweaks we could make to ourselves and steal parts from nature, but I don't think superpowers are going to happen on their own.
So has evolution basically decided that gluten is kryptonite for human beings? What's up with that?
I think a lot of that is not real. A lot of people think they have gluten insensitivity, but no, I mean, probably there's been evolutionary pressure to be better at tolerating gluten because bread is such a staple of human diets. So if anything, I imagine humans are much more capable of having large quantities of gluten than we were in the past, actually.
Well, there is something that's interesting that's happening, though, is you know, we think of ourselves as humans as being kind of a static organism, that, you know, humanity doesn't change, but in fact we are still evolving. Things, you know, our genes are changing, and they are changing slowly, but it does change, you know, century by century, millennia by millennia. And so the idea that, you know, we could keep humanity exactly in one state is also incorrect, right? Not only can, you know, could we engineer ourselves, but we can't stop evolution from happening.
So has our technological advances effectively altered our evolutionary trajectory?
Drastically so, yes. So many diseases would have killed us in the wild when we were hunter-gatherers, and would have been, you know, purged from the gene pool. And now we have, you know, science and medicine and technology, and so issues that would have killed someone hundreds of years ago are no big deal, and that person can have all the children they want. So our evolution is drastically different than what we actually evolved to do. You know, we spent hundreds of thousands of years evolving, where most of that we were, apes that weren't that clever, and so lots of our traits are completely outdated now. The physical aspect humans evolved to be best at. We're used to thinking of ourselves as pretty weak compared to other animals. There's one trait we're better than any other animal on the planet at, and it's long distance running, which is weird and doesn't fit, how we function in day-to-day life, but it has to do with our sweat glands, and we can do lots of heat dissipation, and persistence hunting developed in the savannas of Africa, and it's just completely irrelevant to how we live as humans nowadays. And so we have lots of evolutionary holdovers from that we could get rid of if we wanted, and it wouldn't have bad side effects necessarily.
And that evolutionary advancement serves us well on the Comic-Con floor.
Yeah.
No,
So-
yeah, walking miles.
It was just thinking ahead.
Yeah. Well, and I was gonna say, like, there's also a danger too with technological advances as far as evolution is concerned, and that is that people that also, or children that would have died in the womb or shortly after birth, they do continue, right? Because we've been able to help them. I mean, my son was premature. Before he wouldn't have survived. He's surviving now. So his genes are actually passing on, which means his whatever caused his prematurity, which we don't know, might also give his children or his wife, depending upon how the genetics work out, a chance to have more premature children. And so then you're going into this vicious cycle where you're having more and more prematurity. And so that's true in a variety of different aspects of things. Now, does that mean that we should not have those babies survive? No, but it just means that the evolutionary pressure has changed. And so you may just see different consequences of that comes. Maybe there are good consequences, because other genes that may not have been able to express in different traits are now getting to be expressed. And maybe that's advantageous from a technological standpoint or even a mutational standpoint. So it's just interesting to think about too.
So you mentioned consequences and unintended consequences, unforeseen consequences. Seems like that has certainly been great fodder for film and literature and story. The notion of, boy, this is a great thing we did, oops.
Yeah, I mean, it always goes back to Frankenstein and even before that. But yeah, there's a fear of technology, a fear of the unknown, a fear of where we're going. I mean, thing we haven't touched on, I think it was the topic last year, talking about sort of the meshing of biology and machine, that sort of altered evolution. Yeah, and I think it's a fear everybody has. Science in of itself is sort of pure and noble, but then science always ends up in the hands of capitalists, profiteers, and then it becomes sort of less noble. And so we always wonder about that. And I think two great superhero lessons. Growing up, there's Spider-Man. With great power comes great responsibility. And then there's the Superman dilemma. He had these great powers, and he was asked, what happens if there are two disasters happening simultaneously? You can't be at both of them. You go to the one that saves the most people. So I think those are two things that we continually, I think science is constantly thinking about, maybe, in all their research, those two scenarios that superheroes put into the pop culture conversation. And I think that's sort of a warning against where powers unchecked can go.
It was one of the themes that we explored in Luke Cage season 2, was like, when you are a metahuman, like, how much do you need to interfere with, like, police? Like, how much do you need to interfere in, like, the everyday actions of, like, criminals? I think there was a line in an episode where Rosario Dawson's character tells Luke, it's like, not every siren is for you. And then he's like, well, who else is going to step forward and do it? And so there's also that personal responsibility. It's like, if I have these powers, it's like Spider-Man. It's like, do I let the fire department, like, step in and do their job? Or do I get there first and save as many people as I can? And then it's like, if I'm trying to save these people, why am I not over here saving these people? And if I want to, like, have a life and go on a date, Like, and it's constant. And that was the thing with Luke. It's like it was constantly like he had no personal life because he was, you know, the hero of Harlem, and everyone was expecting him to step in because it was a black community and they didn't trust the police. And so it's like that pressure on him to be a hero that was taking away from his own sense of self as a person.
I think it's difficult, and sometimes, like, particularly when you talk about science and ethics, and then whose responsibility is it to kind of take that last step, right? And that plays into this whole thing. And I think a lot of times in science, we're very cognizant of that, and we stop, and we'll say, okay, this is possible, and we'll leave it there, and we'll never move forward and say, yes, now not only is it possible, but it's also doable, and it's done, right?
So you followed Jeff Goldblum's advice in Jurassic Park. It's like you actually did stop to ask yourself if you should.
Oh, yeah.
Yeah, but then the problem though is, you know, do you even ask yourself that question, or do you say it doesn't matter if I should or not, I'm going to stop here?
Yeah.
And a lot of people just, they stop here.
That's good
right?
to know.
And that I feel doesn't give the opportunity to provide a benefit to society. If you don't give society the opportunity to benefit from the science, then you haven't done enough. But with that comes the opportunity to provide a lot of detriment to society as well. And I don't know how to balance that. I've watched a lot of shows, and hopefully I learn.
Well, I mean, so like along that, right? Do you find? I mean, okay, so mad scientists are great fodder, right?
Yeah.
And I always kind of am like, okay, but where's the good scientists? Because there are a lot of us out there. And I was just gonna bring that up. So that's like one of the things that I love in Agents of S.H.I.E.L.D., right? Like Fitz and Simmons. I mean, they're great. You know, they're great, bubbly, geeky scientists who have a lot of young energy. They're a little naive, you know, and that's great. That's what you need in the lab. But I mean, so do you see, like in your industry, right? Are we moving more towards that, or is it?
Yeah,
still
I think
towards-
definitely, because when I was growing up, it was always the evil scientist,
Yes.
every
Right.
problem in the world. But now, and they still exist, but now it's the scientist that comes and saves the day, and Independence Day, or whatever the movie might be.
Jeff Goldblum again.
Yeah, you're right. It's actually Jeff Goldblum.
I know, it's
You
Jeff
say,
Goldblum.
It's not science, it's Jeff Goldblum. So yeah, I think it's balanced out more. But it's more of the shadow concept. It's like the good science and the bad science. It's nice to see both of them in the same film,
Yeah.
as opposed to just being pure bad or even being pure good. It's nice to see that debate in
Yeah.
film.
So does that debate in film actually make it into the lab and the discussions? Because certainly now, and with grant regulations, et cetera, the notion of ethicists in the lab as being a requirement which is certainly not a bad thing. But how much of what you see, again, in sort of pop culture makes it into those discussions? And is that, if you ever go home, turn on the TV and go, oh crap, I shouldn't have done that today?
Well, I mean, like, so just as Craig was talking about, right, there's good scientists and bad scientists, but I mean, it comes down to, like, where you as a human are going to draw your ethical line. There are certainly scientists that I've worked with who are brilliant, and they want to push every boundary they possibly can, and it's for everyone else to work out the regulations and whatnot, but that we should be able to do it. To some extent, I understand that philosophy and I agree, but I also think, especially in biology, like, you know, you're talking about adding mutations and speeding up evolution, but that in and of itself has unintended consequences because, you know, biology is a fine balance that's had millions of years to evolve. And so if you tweak it or add something more, then you put something else off balance. And so you can wind up having, you know, an illness or something like that as a result. And so I think that you have to think about all the things that you're going to start changing before you change them, because once you change them, that's it. You've changed them. It's Pandora's box is open. Mm-hmm. So, but on the other hand, you know, you don't want to be the country that is left behind, because, you know, Europe or China or wherever, they're doing it and you're not. So you have to balance your humanity's ethics, right, with achievement in science and pushing the boundaries.
Just by virtue of being, such powerful technology, science inherently allows for both good things and bad things. So it's definitely something we have to keep in mind as scientists. You can use genetic engineering to create crops with added vitamins and help combat sickness and vitamin deficiencies in developing parts of the world, and that's actively being done. You can look up golden rice, and that's an objective good use of the technology. But you can also have predatory business practices by big companies that put proprietary gene drives in their crops, and now you have to buy everything from them, and it's so you can do good and bad with science, with genetic engineering, with electricity, with all sorts of technologies in general, and so it's definitely, we need to keep that in mind, but it shouldn't be something that makes us go, oh, we shouldn't do this at all, because we can do bad things with it, because you can do bad things with a lot of stuff, but you can also do good things with it.
Yeah, often the way in which you implement something changes the morality of how you're working with it. And I mean, that's genetic engineering of crops is a really good example of how you can screw that up by bad business practice. And so that's often, in science, we almost never think about that. Those are questions that we often kind of toss over the wall to the business people. And that's something that, I hope more scientists take seriously.
Yeah. I would say it's like the evolution that I've seen just like in the business is moving away from like the evil individual scientist who's like the evil corp. Like big pharma, evil big money, like all of that, and then it's just like the individuals who are just trying to do their jobs but are kind of like puppeteered by like this corporation that is just in it to make money. So yeah, we're kind of moving away from evil scientists into like evil, like faceless entity.
Whatever's over on the other side of the wall that you keep throwing those things to.
Yeah.
Right? That's
Yeah.
where it is, okay.
Yeah.
So we mentioned earlier this kind of confluence of biology and technology and how that's coming together. It sounds somewhat facetious, but I'd love to kind of hear their thoughts. So with this, as we can incorporate electronics into our own biology, are we going to eventually be our own robotic overlords?
Yes. I mean, that's the short answer. There are certain things that I think there's immense pressure out there to have happen, and integration of electronics and biology is one of these things that, for good or bad, I think that the technological community and the investor community has decided this is something that has to happen, and it's going to be pushed as hard as it can to happen as quickly as it can. And for a lot of reasons, right? AI becomes a lot friendlier when you are directly controlling the AI. It's totally under your control, and you get the benefits of it individually, right? And so there's a lot to this that I think people want to see happen, and they're gonna try and push it. And so those are the kind of first. That's why I think things like telepathy. These are the first kind of superpowers we're really going to see happening.
But there's also, I feel like as that's being pushed, that's going to create like an even bigger schism within society, because we all know who's going to be the first to
Yes.
get that tech, and it's probably not going to be many of us in this room. And so, like, would you see, outside of like, Bill Gates being extremely altruistic, like that technology trickling down to just like the regular masses?
That's a really good question.
Well, so I think that this is starting. So I've been watching Humans and Westworld, right? And so I think they're starting to get into this. And so yes, will it trickle down? Yeah, because if you look in those societies that they grow, the older models, right? Like you can start seeing that. But then again, you think about like the iPhone, right? When the iPhone first came out, any of this stuff, right? It was only the wealthy that really had that. And now, like third world countries have smartphones and things like that. So I think and you tell me this, electronics is all about scale, right? So the cheaper electronics get, it comes with scale. So however many people start getting it, then it becomes cheaper to produce. As it becomes cheaper to produce, then who can afford to do it increases, right? So I don't. Yeah. Anyway, I don't.
Yeah, you want to. The question, I guess, really is: this gets back to how you make something actually get out into society. Do you push it towards a a business model that is going to rely on high scaling and getting out to everyone, or are you going to push a business model that's only going to sell to elites at super high markup? And that's the kind of decision that has ethics built into it, and we often don't think about it when we're making the decision.
So listening to this, there's this, I almost picked up on this, really fascinating analogy here, and it's not even an analogy, it's the same thing. So you're doing your work, and someone above you who has the money, who's paying you, is making a whole bunch of other decisions, right? So certainly, again, in the science side, you've got investors, you've got grantors, you've got who are basically driving this. You've got a studio, and you've got a distribution group who's defining this. What's that like on both sides? I mean, you kind of hear the story, you kind of hear the shorthand story of, I went in and the suits gave me all these notes. I don't know what notes are. I like getting notes. I'm guessing you don't. And at the same time, the notion of, again, so you guys have a startup, right? But I'm guessing it's not just money you found on the street that's letting you do it, and there's some folks who are driving you too in terms of how much control do you have over the science you're doing, the technology you're doing, or even the show that you're doing.
Yeah, definitely. As a scientist, you have a vision, a creative vision, in a way, of what you want to do, of where you see your work going, and you can work on it for decades to get it to the point where it's ready to be out there in the market, and you can lose control over it. You have to, in many ways, unless you're independently wealthy, you have to give up some control, and you have to be careful about who you work with. And it can be very frustrating to have those kind of conversations with people where you know it can do a certain thing, but you've got to be able to convince the business folks of what it can do. It's very useful to have pop culture help you do that. And so if you can align what your science vision is with language and storytelling that everyone is familiar with, that's very helpful, because we're not natural storytellers, and that's what's needed in order to really paint a picture of what can happen.
Well, and from the non-business side, right, I rose the ranks through academia, and so what really controls that is the NIH, which is controlled by Congress. And so if you guys out there in the audience want a certain thing to be created, some sort of metahuman thing, and you want scientists to work on it, really you have to go and vote for people that are going to give funding to the NIH. So please go out and do that.
Oh yeah, it's like November 6th.
Right, exactly. And so, but that's really who academia works for, right? Is you guys. And business does too, to a large extent, because you're the market. So if there's something that you're going to the physician with, and you're like, I need a test that does X, and the physician says, well, I don't have a test for you, then cool, we'll make that test for you guys. So that's where I think that it can work really well. But you always have to report to somebody. That's how it goes.
Oh, yeah. We know that.
Yes, but the good thing about Marvel, I think, as a company going their entire history, is they love science. It's silly science when you read about it, but all their superheroes, there's a science basis, and whenever we come up with somebody has a new power, they're like, what's the science behind it? It doesn't have to be exact, but they like to start that conversation. I like to think that Marvel, in a lot of ways, is what Jules Verne was back in the day, which is, he postulated, traveling to the moon and submarines, and inspired people to pursue these things. I think in a lot of ways, Marvel and other, pop culture companies sort of dream up these things that will inspire future generations. Like, we want to make that happen. How can we do that? I read about that when I was a kid. I would like a radioactive spider, by the way. How much?
I can make you a radioactive spider, but it's not going to give you any power, so it'll just be radioactive.
I do like that there's been a trend towards increasing scientific accuracy in comic books even, where, it used to be you get randomly exposed to radiation or something and you develop powers that way, and that's just, not going to happen in the real world. That's like throwing a grenade into a library and hoping the pages fly together and form a new work of Shakespeare or something like that. So now, people invoke agency and some sorts of experiments or genetic engineering, and then you can get away with whatever you want because nature is very adaptable. So as long as you get the right explanations in there, you can have something outlandish be, kind of scientifically feasible.
Well, that's what we did for like season 1 of Luke Cage. It was Marvel who's like, okay, what is the science behind how Luke's skin worked? And to their credit, they went out of their way, like they found a science, I believe his name is Itai Cohen, who teaches at Cornell, and they set up a video conference between the writers and him, and we just asked him questions for like 90 minutes. He's like, well, if the science behind this, I think was like abalone shells was like his like explanation, like that's what you could say is happening to his skin. It's like the stretchy material, and he also brought up like Velcro. You could say that it's like the skin is like coming apart and then coming back together to push the bullet out. And so we're all like taking notes, and like that's what essentially Rosario Dawson was explaining in season 1 and season 2 about the realistic way Luke's skin works. But yeah, Marvel is they are very into the science, which kind of like inside baseball, it didn't necessarily help them with Iron Fist because he got his powers by punching a dragon in the heart. And so it's like, you're gonna have to let that one go, you guys.
Yes. Or just put the word quantum in front of it.
Yes, a quantum dragon.
Yes, the quantum. Boom.
When in doubt, go quantum. All right, so let's go quantum to the audience, shall we? Let's get some folks on up there. We've got a microphone. Get some questions of the panel.
So you folks were discussing how as things scale, they get cheaper. Mr. Sandberg is a smart graduate student, but what he does now used to require a doctorate like Dr. Barron to even understand. So as biology gets cheaper, why don't we get zombies faster?
Wait, you want zombies?
Oh God, I love zombies.
I think that's actually something to be a little concerned about. We are understanding bio more and more, and it is fun. It's a very powerful technology. Could be, game changing, but it's fundamentally different from some other technologies like nuclear power, where possibly, figuring out bio stuff is probably more difficult. But no one's going to be building nukes in their basement. That's confined to government-level operations. But there's nothing in principle preventing someone from learning enough about bio and bioengineering. And it's very cheap to order synthetic DNA and make your own constructs. And it's only dropping in price. And so I think there are legitimate, serious concerns about bioterrorism and the kind of things people could do by making some sort of gene engineering weapon that could spread through the population. So we do need to keep that in mind.
So at some of the conferences we go to, science-wise, there's a company called Backyard Brains that sets up a booth and they sell educational equipment. And one of the things they sell is a little kit for you to turn a cockroach into a zombie cockroach, and you can control it and drive it around. And so, we could make zombies, but we've decided not to. But yeah.
Zombies also something we can steal from nature. There are lots of organisms that zombify other things and inhabit their brain. So it's something that can totally happen. That's a feasible thing.
I hope everybody appreciates we're having an actual conversation about
Bringing about the zombie
bringing about
apocalypse.
zombies. I love this.
This is where those worlds collide. Right? There we go.
Okay, I'm one of those dinosaurs that has a degree in philosophy, so when you guys were talking about ethics, I was over there going, oh my God, you're making the assumption that there's free will. And from what I understand, and I'm not a scientist, so maybe you guys can comment on this, the latest in neurochemistry is that there is very little free will that we human beings have. So I would like to hear you guys comment about that, as far as, everything's bio, like the studies that show that judges are more likely to convict if they make a ruling when they're hungry as opposed to when they come back from lunch, that kind of stuff. So
I think free will is a useful, emergent, higher level property to discuss, even if it doesn't have basis in the fundamental workings of the atoms that make up our bodies. Just because, in principle, if you had an all-knowing supercomputer that knew the state of every particle in your body, it would know you perfectly and you wouldn't have free will and your future would be preordained. That can be true, and yet there is no possible way to know all those states. And so I like to think of myself as having free will, despite also realizing that I am merely a collection of atoms obeying the laws of physics. And I think we can have both when free will is valid at the scale of humans and societies, and when you get to fundamental physical laws, it's not really there. But then again, temperature is not in the fundamental physical laws. That's also an emergent property. Lots of things are emergent.
Yeah, well, and I also think too that there's so many different combinations of where neurons and neurochemicals go in your brain with every input that you get. That for our moment in time, we do have free will to make a choice. We can either give in to our impulse to do whatever our body naturally tells us to do in a split instant, or we can refrain from doing that. So I think that's where the free will choice comes in.
You guys talked a lot about basically like biological augmentation for the body, especially using electronics and things like that. But there's also the sort of other side with AI where it's not attached to humans really at all. It's its own separate entity, especially because of the implications of AI kind of taking over people's jobs and things like that. Do you ever feel like there's a race between biological augmentation and AI? Who could get there first? And if so, who's winning?
Yeah, I definitely think there's a race. And I think that I think right now that AI is winning because we're not able to improve people to the point where they can feel like their jobs are trivial or can be automated from the work, right? The work is still work. I'd like to do better in the race.
They also work together, though. AI is being used to make biological discoveries, and they have, you can have AI drive a car, and that's not going to affect your ability to genetically engineer disease out of people. So they can be complementary and also go in different directions.
Hi, I'm coming from more of an indigenous perspective of communities, not only here but all over the world, that believe that what people call metahumans now obviously have existed throughout time, where people can heal, people can manipulate the elements like fire and wind. The things that I've seen in things that people talk about indigo children that started in the theory started in the 1970s by a woman, Nicole Ann, and others. Does the scientific community believe that metahumans already exist?
I don't think that the scientific community believes that metahumans already exist, but neither could we rule out completely the possibility that people have done things in the past that we can't explain. I think that's probably the best way to put it.
I would just say Marvel is owned by Disney, and if metahumans existed, they would have found them because it would reduce our effects budgets considerably.
Yes. And when you do, can you bring them by the lab?
Yes, we will.
Yeah.
I'd like to study.
We will talk to Disney about loaning them out.
Oh, cool. You can do a licensing agreement.
Earlier you mentioned about later on in the future having prosthetics where body tissue grows over it to create a functioning arm or leg or limb. I imagine the next step will be completely replacing the body with mechanical parts, and essentially becoming androids. How far off into the future would something like that be?
We can already replace a lot of body parts right now with metal. If you think about metal hips and things like that. I think it's still very, very far in the future, mostly because the biggest problem is finding materials that don't agitate the immune system in the body. And so once you figure that out, and that's where material scientists are really, of need, that's when you'll start making great strides in that direction.
Limb replacement has actually reached the point now where you can have a fully artificial prosthetic leg or hand and link up electronics and have electrodes in your brain and work out how the signals work. You have to do some training and physical therapy, but you can actually control these devices just by thought. That is real technology people have in prosthetic devices nowadays. So we're not that far removed from cyborgs.
That was actually one of that piece right there. We found an article for our Misty Knight character, who, spoiler alert, loses her arm in the Defenders and gets her prosthetic arm this season. And so that was when Marvel was like, okay, you want to give her a robot arm. how is that going to work believably? And so we brought them that article. It's like, it's happening now, you
Yeah.
guys, so this is not that far off.
Not
Please
even
just let us
sci-fi.
give her a robot arm this season.
Well, and I think there's a lot of drive, especially in the military community, because of all the wars that are
It was
going
a vet,
on.
yeah.
To put a lot of money into the DoD for creating these really amazing prosthetics. And which is great for us scientists who want to work on that, especially developmental biologists, and engineers, so, yeah.
As science gets closer to our metahuman, like and just cyber engineering and all that, how worrisome would like a black market for that actually be?
That's very worrisome.
Yeah.
I mean, already, we've talked about like ethical issues and all, regulatory affairs and things like that, and there's already such a push in science to be first at something that's what drives people to skip things. And the risk in allowing those people to get there first is they start off and they're outside the market, and we start with the black market rather than the way it should be.
Hi, so I am not a scientist. Gonna put that out there first. It's not my forte, but I watch Agents of S.H.I.E.L.D., so I'm okay. So I just have a question from a few studies that I've heard about or learned about. For instance, the study that simply sending love, if you will, sending energy, encouraging thoughts to a plant can help it grow better, can help it thrive. And then there's the first law of thermodynamics in that anything that is, always has been, always will be, simply flows in and out, but cannot be destroyed or created. So with those things in mind, why are telekinesis and maybe even telepathy not a thing right now?
That's a biology question.
Oh, great.
I asked them the same question.
Yeah, right. Yeah, thanks. I don't know. We don't think hard enough. I mean, I think it comes back to energy, Brett.
I think, yeah,
energy.
actually.
It's just that, I mean, it goes back to, you even brought up, the brain doesn't produce enough wattage or voltage. So if you were gonna send out enough energy to lift up a boulder and shoot it at someone with your head, right? You would have to exert a lot of heat. You would fry your brain. So, I mean, I don't know, when we can evolve to the point where we won't fry our brain, maybe we can have telekinesis.
There's also, things that physical technology like electronics are just better at than biology. And so maybe, mind reading is feasible in principle because your thoughts are just electrical impulses racing around your neurons, and we can measure those in MRI machines. So we can kind of read thoughts in a way now, and we're learning more how to tie the patterns we see to actual thoughts. So in principle, you could read minds if you had really strong sensing technology that could detect the magnetic fields going on in someone's brain. But when you crunch numbers, the energy scale of that is so minuscule that, for that to evolve as a trait that an organism could sense another's mind state from a distance is just kind of not easy to happen. But it's maybe something we could do with technology.
So has Marvel asked you yet to come up with a science explanation for telekinesis?
Not yet.
Well, I am reading the mind of the people in the back who are telling us to get that out, because someone else wants to come in and talk about something else. I don't know why, honestly. All right, so let's thank Craig, Akila, Francis, Brett, and Troy. Thank you all for coming out tonight. Have a great rest of Comic-Con and enjoy your time in San Diego.
She wants a photo.